Hi there. In this screencast, I'm going to create a sample class that's going to have instance variables, constructors, getter and setter method, and also an additional helper method. So here we go. All right, in NetBeans, I've already created a file that's called sample class, and now I'm going to declare several instance variables. So remember, instance variables must, I can't emphasize this enough, must be labeled private. So you should always make them private. So I'm going to declare let me do this. Let me do an int variable, a Boolean variable, a string variable, and maybe I'll also do a double variable. W. So that would be W. All right. So the next thing that you'll typically see in a class, the traditional order that classes are structured, are any constructors. I might add that although it's possible to initialize instance variables in when they are declared, right when you're declaring them at the top of the class, traditionally, or at least in AP computer science, they wait till the constructor to initialize them, and they don't initialize them right up here, meaning they don't assign them values, they just declare them. Okay, so the constructor is always public, and it must be labeled public. All right, it does not have a return type. It looks like a method, but it's really a specialized method without any return type. So it's just public, then the exact name of the class. All right, so a no-args constructor is a constructor that has no parameters. So there are no arguments applied to it when it is called. So, and typically, what a no-args constructor does is initialize the variables with their initial values, and it always gives them some default values. So when over in the class with the main method, if I want to make instances of sample class, I would not be able to, and I use the the no-args constructor, my code would not be able to assign values right at the time a sample class object was instantiated. So I'm just going to make up some values to assign. And let's see, W equals 5.0. Okay, so I'm done. Oops, I mistyped it. W. All right, so I'm all done. Now I'm going to make a constructor with arguments that is also going to exhibit chaining, meaning it's going to initially, its very first line, it's going to call the no-args constructor. So this may be done typically so that just to avoid rewriting code. So for example, if in my constructor with parameters, maybe I only want to customize values for Z and W, but I still want X and Y to have their default values of 0 and true. Well, rather than have X equals 0 and Y equals true, which would be 2 lines, I'm just going to call the no-args constructor of and then, which is going to give values of 0 and true. It's going to give values of hello and 5.0 to Z and W, but then immediately in my constructor, I'm going to overwrite those values with the parameter names. So here's what it would look like. So I'm going to, let's see, supply, have parameters for Z and W. And I'm going to use names that are similar to Z and W, like Z1 and W1. And those are going to have be the same type as the actual variables that you're going to be assigning values to. So I'm going to say this. All right, that's going to call the noargs constructor. Now notice it's going to call the noargs constructor because I did not put arguments there. It could call another constructor. Maybe I have three constructors and one of them has one argument. Then I would just put a value to use as the argument for the parameter of any such constructor. All right, so getting back to this one. So now I'm going to say z equals z1, and I'm going to say w equals w1. Okay, so now over in, let's see, over in my main method, I'm going to say, okay, sample class, if I can get the caps lock right, sample class x equals new sample class. Okay, that's going to make a sample class object that I'm going to assign to a local variable named x, and it's going to call the noargs constructor. And now if I say sample class x2 equals new sample class, and then let's see, what were my z and w values? They were a string and a double value. So I'm going to do, let's see, I'm going to do hello there. And I'm going to do 5.78. All right. So now if I print out all the values of the variables, and I'm going to have to use getter methods to do that, so I'm not going to be able to actually print them out. But if I put in breakpoints, then I should be able to go in and see what the values of my local variables are. So let's see if I can put in a breakpoint. Okay, there we go. So I'm going to do debug file. Program should come to a grinding halt right there. And now let's look and see what x and x2 are. X had the noargs constructor called to make it. So sure enough, I have 0, true, hello, and 5.0. And then x2 called the constructor with two arguments. So sure enough, I have 0, true for x and y, which comes from calling the noargs constructor. And then I have hello there and 5.78 for z and w, which are what the arguments I supplied for the constructor with arguments when I called it. So that's an explanation of the constructors. Now let's move on to what getter and setter methods are. So getter and setter methods traditionally come after constructors, and you can think of setter methods as kind of mini constructors. Their purpose is kind of similar. They're to change the values of the instance variables just like a constructor does, except traditionally or conventionally you have one setter method per variable. There's some IDEs that have automated processes for generating getter and setter methods, and basically what that process does is it goes and looks at every single instance variable and just writes a generic setter method based on the name of the instance variable and the data type. And actually, let's see. So let me do the setter methods first. So as I said, the setter methods similar to a little bit similar to constructors. They're always void methods and they're always public. They must be public because they're going to be used by other classes in other classes to set the values of the instance variables of an object of this class. So I'm going to say, let's see, I had x, y, z, and w. So I'll just make two of them. I'll make them for x and y. So x is an int value. So that means I'm going to need an int parameter. So I'll say int x1. And then setter methods are always void methods because they always do something. They don't return any value. They actually accomplish a task. So, and the only task they accomplish is to assign the value of the argument supplied for this parameter to the instance variable. So over in the main method now, I can, let's see, where was I? There we go. Over in the main method, now that I have a constructor for the x variable, and actually x here is a very poor choice because although you can name instance variables and local variables the same across different classes, it can result in your code being a little confusing for you, especially as a new programmer. So I'm just going to change those variable names to p and q. So now, after I've created p, I can say p.setX and provide a new value. All right, and now when I run the program, if I look at p, my p object, it should have those initial values, but x, y, and z should now be, or let's see, x should now be 6 because I modified it. So you call a setter method after constructing an object that modifies the one instance variable of the setter method. And setter methods are also called mutator methods. You'll hear that kind of more formal name. I think it kind of sounds Space Odyssey-ish and a little bit sci-fi. So I like setter and getters because, and most people do too, because for one thing they rhyme. So, okay, I think that's why people like them. At least that's why I like them. Okay, so now I'm going to make a setter method for the y variable. So I'm going to say set y, and y is a Boolean variable, so I'm just going to have one Boolean parameter. And I'm going to say y equals y2. All right, now you can use the same name as for the parameter and for the instance variable if you want. However, if you do that, you need to say this dot y equals y, and that's how Java will distinguish between the instance variable and the parameter. This dot y is the instance variable, y is the parameter. The AP curriculum, as I've said, doesn't use that convention, so it usually just creates parameter names that are slight variations on the instance variable. Okay, so then we have what are getter methods? Getter methods actually return the value of a private instance variable for an object in another class, so that the code in the other class can access the value of that object. So just like a setter method changes the object from another class, a private instance variable, the getter method supplies the value to the other class. And that other class is typically called the client class. And the class that the setter or getter method is typically called the server class, because it serves up a value through its getter methods to the client class. All right. You don't need to know that for the AP curriculum, but it's just something that you may hear in programming circles. Okay, so the getter methods must also be public because they're going to be run from other classes, and their return type, well, they're going to return a value of a variable, one of the instance variables, so their return type has to be the same as the instance variable whose value they're returning. So for x, x was, let's see, how soon I forget, an int value, so I'm going to say public int get x. And getter methods do not have parameters because they don't need one. All they do is supply a value. Okay, so, and they typically have a single return statement, or you could have a return statement embedded in a conditional statement. So I'm just going to say return x. So that's my getter method. And I'll do one for y as well. And it's going to be get y, and I'm going to say return y. And I'm getting flagged because y is a Boolean variable, not an int variable. So its return type has to be Boolean. So now over here in my class with the main method, I might say, okay, system, actually, let's see, uh, system.out.println. Now, if I just say q.y, I'm going to get an error that says y is not recognized in the context. No, it says y has private access in sample class. I can't access it from code in Java application 11. So, however, I can say get y. All right. Now, and it has to be q.getY, of course. So you always call a method for a specific object. All right, so now this should print out, let's see, what was my, well, let's just see what happens. Okay, there we go. It's true. And that's because true was the value that was assigned to y when the object that is assigned to q was created or instantiated. All right, moving on. The last thing that you may encounter are some other methods that are useful and need to be accessed either just internally or within the class itself, or externally, meaning from another class. So the ones that you need to access from another class are going to be public. And let me do one with string. So I'm going to say public string, and I'll just say string name. And let me call my, I'll call it greeting. So it's going to return a string value, and the greeting is going to be return hello, and then plus name. Okay, so now I'm going to go over and I'm going to try running this for Q. So I'm going to say, let's see, q dot system.out.println q.greeting. Okay, and I need to supply the value, Mr. Hayden. All right, so now I'm going to expect, I would expect it to print out, it's going to call the greeting method for Q, which is a public method. And what does the greeting method do? It takes in the string value that is supplied and tacks hello in front of it. And you know what? Let me just tack on an exclamation point in the end to make things fun. All right, so now I'm going to debug my project and see what I get. Oh, that's right. I have a breakpoint. I forgot to remove the breakpoint. So let me just, hello, Mr. Hayden. There we go. All right. The last kind of method that you might run into are private methods that are sort of like internal helper methods, and they only are needed within the class itself. Maybe they compute something based on the instance variables that assists in some other method only within that class. They don't need to be used anywhere else for any reason, only within that class. And those methods will be private. So you can tell, of course, because they're private, you would only be able to utilize them or reference them in code within the class itself. So if I, in this example, if I went back to sample class and said, okay, private, I'll just do some mathematical function, even though I know that are already built into Java, I'll just make my own version of it. So I might say public double square root double D, and I'm going to say return math.sqrt D. All right, so now I have a private method. If I try to call it from anywhere else, I'm going to get an error. But I can call it within any of my other methods. So I might, let's just call it in greeting for the heck of it. So I'm going to say, and let's see. So instead of having one parameter, I'm going to have two parameters. Double D1. Okay, so, and I'm going to say, and the square root of plus D1 is, and then I'm going to call my method, my internal helper method. So I called it square root D1. And I think I need spaces there and a plus sign. Okay, so now when I run my project, oops, you know what? I need to use a parameter. So I need a double value to call it with. So let's use W instead of D1. So whatever the value of W is at that time for that object, it will compute the square root of it. So in my case, well, let's just see what happens. Oops, where's my, still have an error, canceled by user. Run anyway. All right, let's see if I can see where I'm going. Oh, yes, I know what it is. I forgot to supply it a value. Oh, and you know what? I actually, now that I'm just taking the square root of the instance variable, I don't actually need a parameter. I can just reference the instance variable itself. Because when I reference W, it immediately knows that I'm talking about the instance variable W. All right, so now let's try it. Yep, there we go. Okay, so if I try calling square root from another class, I'm going to get an error. So if I say, you know, system.out.println q.square root, you know, x, I'm going to get an error that says, you know what? Let's see. Let's just do, hang on. I'm sorry, momentarily confused here. Square root is, right. So if I look at square root, it's a double value. So that's what is wrong. I just can't reference it anywhere in the class or the main method because it is, like if I say, you know, double f equals 4.5, and I say system.out.println f dot square root, or square root f, I'm not going to be able to do it. Okay, I hope that was helpful for me re-explaining everything that will be on the quiz on Friday. And maybe I'll do this again if you guys like me doing this. All right, cheers, and we'll see you on Friday.